calculated by the Tejagi's theory, that was QU is equals to C dash NC plus here was Q naught and Q plus half gamma B and gamma. This will become this, and this will be substituted as it is, plus 1 by 2. This gamma will be turned as submerged unit weight, and the equation becomes like this. So what if the condition dW is equals to 0? It means A is equals to dF. What if the water table reaches over here? So dQu is equals to C dash NC plus gamma dash. This is 0. So this is 0, and this becomes gamma dash dF and Q plus 0.5 gamma dash B and gamma. So if dW becomes equals to dF and A is equals to 0, then QU is equals to C dash NC plus gamma dF and Q plus 1.5 gamma dash B and gamma. Okay, so for the second case, if the water table is located below the base of the footing, below the base of the footing means Q naught is equals to gamma dF. It will remain the same in the equations of QU, that is C dash and C Q naught and Q plus half gamma B and gamma. This gamma will be changed, that is the new gamma is equals to gamma dash plus B upon B gamma minus gamma dash. So this small b is the depth of the dry soil below the footing of the base of the footing up to the water table, and B is the width of the footing. Hence QU becomes C dash NC plus gamma dF and Q plus 1.5 gamma dash plus B upon B gamma minus gamma dash B and gamma. If small b is considered as 0, means this water table reaches up to here, the equation becomes just like the above one. That is, if we put the word 0 here, that this term becomes 0 and gamma dash B into n gamma, and this becomes the same. And if B becomes equal to B, then the equation becomes like this. This becomes B cancelled out. QU is equals to C dash NC plus gamma dF, that is unchanged, Q plus 1.5 B gamma and gamma, means same as the equation which was initially derived with the help of Tejagi's bearing capacity theory. It means when the water table is below the base of the footing after the width of the footing, then it will have no effect on the bearing capacity. Now bearing capacity for square footing and circular footing. So what it will become? It will become QU is equals to, just write the same equation first, NQ plus gamma B and gamma. Just have to add 0.4 over here and 1.2 over here. This will be the equation for square footing, where B is the dimension of each side. And what is for QU? QU is equals to same 1.2 C dash and C plus gamma DF and Q plus 0.3 gamma B and gamma, where B is the diameter. So capital D has been taken as the depth of the foundation, hence let it be the B. And this NC, NQ and N gamma are same as that of the strip footing. Now some other experiments were also done by some other geotechnical engineers. One of them was Hazen. In 1961, he gave an equation for the ultimate bearing capacity. According to him, QU is equal to C. He added up some factor SC, DC, IC plus same Q and Q. This time SQ, DQ, IQ plus 1.5 gamma B N gamma, that was same. This time S gamma, D gamma and I gamma. So as we know, NC, NQ and N gamma are bearing capacity factors, and Q is the effective surcharge at the base, that is gamma DF, and SC, SQ and S gamma are shape factors accordingly. DC, DQ and D gamma are depth factors, and IC, IQ and I gamma are inclination factors. We can write over here SC, SQ and S gamma are shape factors. DC, DQ and D gamma, DC, DQ and D gamma are depth factors, and IC, IQ and I gamma are inclination factors. According to Hazen, the value of NQ, NC and N gamma are different. NQ is 10 square 45 degree plus phi e to the power pi 10 phi dash. NC is equals to NQ minus 1 cot phi dash, which is 1.80 NQ minus 1 tan phi dash. And shape factors. Shape factors are for different shapes, like shapes are continuous or strip footing. Second, rectangular, footing or square footing, and circular footing. So this kind of 4 footings have different values of shape factors, like SC, SQ and S gamma. So SC, first of all, SC for continuous footing or strip footing, this is 1.0. For rectangular footing it is 1 plus 0.2 B upon L. For circular and square footing it is same. And SQ 1.0 strip footing 1 plus 0.2 b by L for rectangular one and 1.2 for both square and circular. S gamma is 1.0 for strip footing, 1 minus 0.4 b by L for rectangular, 0.8 for square and 0.6 for the circular one, where L is the length of the footing and B is the width of the footing. B is length of the footing. Now, what are the depth factors? Depth factors are dc, dq and d gamma. dc is equals to 1 plus 0.35 df upon b. Here 1 plus 0.35 df upon b, and d gamma is equals to 1, where dc is equals to dq are equal for phi is more than 25. If phi is equals to 0, dq is equals to 1. And what is df? df is depth of the foundation and b is the width of the foundation. Now at last, inclination factors. IC is equals to 1 minus H upon 2C BL. IQ is equals to 1 minus 1.5 H upon V. The I gamma is equals to IQ square, where H is the horizontal component of inclined load. Horizontal component of the inclined load. If the load is inclined, then only inclination factors will be applied. Now basics, bearing capacity equation. So Vesic in 1973 gave an equation of the bearing capacity and his own factors, that is NQ, NC and N gamma, and shape factors SC, SQ, S gamma, depth factors and inclination factors accordingly. And what the equation was just like same as the Hessen's equation, just similar to that, where SC, SQ, S gamma, DC, DQ, D gamma, IC, IQ, I gamma were the shape, depth and inclination factors as well. But for the shape factors and NC, NQ, N gamma and depth factors and inclination factors, Vesic has had some different values. Like first of all, we have to write the equation QU is equals to NC, CNC, SC, DC, IC plus Q, NQ, SQ, DQ, IQ plus 1.5 gamma, B, N gamma, S gamma, D gamma and I gamma. These are empirical formula which have proved by the respective geotechnical engineers, and their significance is with them only. So we just have to follow them, and hence what is the NC, NQ and N gamma over here? NQ is equals to 10 square 45 degree plus 5 by 2 e to the power pi 10 phi. Similarly, this is phi. Similarly, NC is equals to NQ minus 1 cot phi. N gamma is equals to 2 nq plus 1 tan phi dash. And shape factors are strip, this is important, rectangular and circle and square basic give the same shape factors. First of all, SC, that is 1 for strip footing, 1 plus B by L and Q upon NC, and 1 plus NQ upon NC. SQ is 1.0, S gamma is also 1.0, this is 1 plus B by L tan phi, this is 1 plus tan phi, this is 1 minus 0.4 B by L, this is 1 minus 0.4, that is 0.6. So these are the shape factors. Now depth factors, DC is equals to 1 plus 0.4 df upon B, dq is equals to 1 plus 2 tan phi dash 1 minus sin phi whole square into df upon dB. This must be rewrite over here. dq is equals to 1 plus 2 tan phi dash 1 minus sin phi dash whole square df upon B, and d gamma is termed as 1.0, and the inclination factors are IC is equals to IQ is equals to 1 minus alpha degree divided by 19 degree whole square, and I gamma is equals to 1 minus alpha degree divided by phi dash, that is shearing resistance whole square, where alpha degree is inclination of load. Now there are a few topics like plate load test, its procedure, its results, its limitations, that are expected to be studied by the students, and in the next lecture I'll upload some numericals for the main exams perspective, and hence this is enough for today. Thank you all.